All right, what's up, grade nines? Happy Friday. It is your last lesson before spring break, so that's exciting. We are going to finish our section on powers and exponents today. So unit 3 will be finished after today. Today we are going to focus on the exponent laws number 2. So the second section of exponent laws. Just a reminder that I posted a student progress check on the Google form, on a Google form on the Google Classroom. So I'd love for you to go fill that out. I'm just trying to make sure I have an idea of, where everybody's at in terms of how this is working for you, what we can be doing differently moving forward to make sure that this is the best and most fulfilling, kind of educational experience we can get, given the circumstances. Obviously, I know it's not ideal, but we are making the best of it. I hope you're all doing well. I certainly miss seeing all of you in class every day, but I'm sure that you are all just hanging in there just fine. So that being said, let's move on. I just had an idea, actually. I will post a riddle for you in the Google Classroom because it's Friday. And so that means that we do a riddle on Friday. I'll post one in the Google Classroom for you. Now, let's move on. So today we are discussing the second section of exponent laws. On our next lesson, so you'll have this week to just kind of hang out and, take care of yourselves, relax, maybe, just take some time to focus on you and those around you rather than just thinking about maybe school and stuff like that because it's spring break. But we do still have to stay home and stuff like that, which is not ideal, but, we're all doing our part, right? So that being said, I won't speak to you again until Monday, formally in the sense of a lesson. Now, if you have any questions about math, if you are trying to get caught up over the week, if you want to, you can do that. Just shoot me an email or post on the classroom. You guys have been doing a good job of interacting on there and on the Google form. So let's just try to keep that up. For those of you that haven't gotten in contact with me yet, I do need you to try to do a better job of that because I need to keep an eye on where everybody is at in the class. Okay? All right. So, exponent laws number 2. In the last lesson, let's just take a look at what we did in the last lesson just to remind ourselves. We discussed the exponent laws part 1, where we did the exponent law, the product of powers, the exponent law for the product of powers, and then we did the exponent law for the, quotient of powers. Remember, quotient is just a fancy math word for division. Remember, when it was division, it was, if it was a to the m divided by a to the n, it was am minus n. And then if it was a to the m times a to the n, it was a to the m plus n. So we'll be building off of that a little bit today. We're now going to be discussing what would happen if we took a power to another power. Whereas in the last one, we talked about what would happen if you take a product or a quotient to a power. Now we're discussing what happens if you take a power to another power. Let's use some fun colors because they tend to show up a little bit better on here than would in class. All right, so how would you solve the following? So how would you solve the following problem? So again, we're looking at what happens if we take a power to another power, or if we take the power of a product or a quotient, and then add that to another power. So what does this actually look like? 3 to the 2 to the 4. Okay, how would you solve the following? What is it going to look like? Well, remember, 3 to the 2 is just a number, right? We actually probably, most of us know what that number is. 3 to the 2 is just 9. It's 3 times 3. If it's just a number, then that means raising it to the 4 doesn't make it look any different than anything else we've seen in this class. If I had 5 to the 4, I would just write out in my multiplication form, my repeated multiplication form, I'd write out 5 times 5 times 5 times 5. In this case, let's write it out like that. 3 to the 2 times 3 to the 2 times 3 to the 2 times 3 to the 2. That's all that looks like. Okay. Now, if I wanted to go even further, let's break each of these down now. And what that gives us is 3 to the 3, sorry, 3 times 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 3. All right, a little bit tedious there. Let's do one more little tedious step here. Let's get rid of these brackets and let's actually just write this out how it is. 3 times 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 3. So that's 1, 2, 3, 4, 5, 6, 7, 8 of those. Remember, that means that it's 3 to the 8. This is our repeated multiplication form that we've learned about in the past. So how does 3 to the 8 relate to 3 to the 4, or 3 to the 2 to the 4? How does it relate to this? Okay, that's kind of what we're trying to figure out right now. Well, how do 2 and 4 relate to one another to give us 8? Basically, what it's saying here is that it's 3 to the 2 times 4. That's going to give us 3 to the 8. All right, so this is our final form right here, is 3 to the 8. Sorry, not this whole thing. 3 to the 8 is our final form right here. But it comes from the fact that we take this 2 and we multiply it by the 4. Okay, we multiply it by the 4. Now, if I wanted to show you this in one other way, remember, let's say recall here, from our last lesson, in our last lesson, we said that if I have 3 to the 2 times 3 to the 2 times 3 to the 2 times 3 to the 2, well, remember from the rule of the product of powers, is that this is actually 3 to the 2 plus 2 plus 2 plus 2. Okay, and that also just gives us 3 to the 8, which relates very nicely there, because this is just 3 to the 2 times 4, right? That's 4. So that's kind of our idea here. Here it is in kind of fancy terms. To raise a power to a power, we have to multiply the exponents together. So a to the m times, sorry, a to the m to the n is just the same as a to the m times n. Okay, this is where a is any integer except for 0, and m and n are any whole numbers. Let's try a couple examples. So write the following as a single power. So -7 to the 3 to the 2. So using our rule from right up here, I have a -7 to the 3 to the 2. So all that means is that this is just -7 to the 3 times 2. 3 times 2 is 6. So our final answer is just -7 to the 6. You can try a few more of these on your own. I'm going to keep going. If you want to pause and try some of these on your own, you can. We've got the negative sign out front here. So remember, that always stays out front. And then this is just 2 to the 4 to the 5. Well, from what we saw up here, 3 to the 2 to the 4, this is just going to be 2 to the 4 times 5. Okay, which is -2 to the 20. Remember, if that negative is not inside of the brackets, it just sits out in front the entire time. And finally, 6 to the 2 to the 7. This one's pretty straightforward. We just have 6 to the 2 times 7. 2 times 7 is 6 to the 14. So that's pretty straightforward. That's our first one right there. So if we see them on the outside of brackets and we're raising a power to another power, so this is basically the power of a power, we multiply the two exponents together. All right, let's move on. So now, what would you do if you had to have a product of powers? So you have a product of powers. This one's going to get a little bit tedious as well, because we're going to write it out as repeated multiplication form. What this is going to look like is 3 times 4. We take what's inside of the bracket, And we do it 5 times. That's what the exponent 5 is telling us. 4, and then 5. So I have them 5 times there. 1, 2, 3, 4, 5. Let's do this one more time, but let's get rid of all the brackets. And what this is going to end up looking like is just a pattern. One, two, three, four, 5. And then notice, right, you've got all these 3s. You've got all these 4s. Let's just write them right next to one another. 3 times 3 times 3 times 3 times 4 times 4 times 4 times 4. I only did that 4 times, I think. Annoying. Make sure you do it 5 times. I'm just going to white out here and add at the end. So this is times 4, and I was supposed to have another 3 in there. So I have 1, 2, 3, 4, 5 3s, and 1, 2, 3, 4, 5 4s. Now, let's do this. Put brackets around these like this. And now all of a sudden, this is looking a lot more familiar. Repeated multiplication form from our last notes. This is just 3 to the 5. And then times 4 to the 5. What's 3 to the 5 times 4 to the 5? Well, we could just write that out as, just get rid of that multiplication symbol. This means the exact same thing. It's 3 to the 5 times 4 to the 5. This looks exactly like what we have down here. So this is our next exponent law. This is the exponent law for the power of a product. If I have a times b inside of a bracket raised to the m, well, that exponent just gets put up above both of those values. So it's 3 to the 5 times 4 to the 5, or a to the m times b to the m. So let's do a couple examples. This ends up becoming quite straightforward then, because if we have -7 times 5 to the 2, this is the same thing as -7 to the 2 times 5 to the 2. That 2 gets multiplied throughout. And what this ends up becoming, what's -7 to the 2? What's -7 squared? 49. And 5 squared is 25. 49 times 25 is 1,225. Okay, let's do the next one. Oh, got my pencil. All right. The negative is out front. So negative, and then 3 times 2 to the 2. Well, that is just 3 to the 2 times 2 to the 2. Okay, which is equal to -9 times 4. -36. So it gets tacked on to each of the values inside. All right. We are getting there. We are almost finished. Now, since we've talked about multiplication, it would only make sense that next we move on to talking about division. So how would you simplify this expression? Let's do the same thing that we did last time. Let's write this out in repeated multiplication form. Okay, so let's write this out as a repeated multiplication. So this would be 5 over 6 times 5 over 6 times 5 over 6. Let's get rid of the brackets. So it'll look the exact same, 5 over 6 times 5 over 6 times 5 over 6. But all of a sudden it starts to look like, remember, when you're multiplying two fractions together, you multiply all of the numerators and all of the denominators. So let's do exactly that. And what we'll get is 5 times 5 times 5 in the numerator, and then 6 times 6 times 6 in the denominator. This looks like it's going to be a base 5 raised to the exponent 3, and over this, which is base 6 raised to the exponent 3. So look at that. All of a sudden, 5 over 6 to the 3 is the same thing as 5 to the 3 over 6 to the 3. Okay, so that's what happens. Again, just like with the multiplication, it ends up tacking onto that one and onto that one. So there it says, it says it right below there for us. A over b to the n is the same thing as a to the n over b to the n. Let's take a look at what that looks like with some examples. 24 divided by negative 6 to the 4. Let's write this out in terms that we're more familiar with. 24 over negative 6 to the 4. Now, using our rule, we know that that 4 comes in and it latches on right there and puts itself right there as well. So this becomes 24 to the 4 over negative 6 to the 4. Now all of a sudden we just need to do these two parts separately in our calculators and we'll get the answer. 24 to the 4, I've already done it in my calculator, is 331,776 divided by negative 6 to the 4, which is 1,296. So there you have it. Your answer is 331,776 divided by 1,296, which should give you 256. Oops, wrong color. Okay, moving on. Nothing tricky about this one. We're following the same rule, 78 over 13 to the 3. That just means that it's 78 to the 3 over 13 to the 3. And then we just evaluate those. 78 to the 3 is 474,552 over 2,197, which is 13 to the 3. Divide those and you get 216. Check to make sure I did that right. I have this written down here. I could have made a mistake. So double check that in your calculators just to make sure that you get the same thing as I do. And if you did, we should be ready to move on to the last page. So this is the last page of the booklet. Now we're taking everything that we've done so far and we're applying it to orders of operations. That's usually our last step to make things a little bit trickier with these types of problems, is taking everything we've learned in the past and then making one big question out of all of it. So 3 to the 2 times 3 to the 3, all of that raised to the 3, minus 4 to the 3 times 4 to the 2, and then all of that raised to the 2. So I'm going to first look at inside of the brackets, right? Orders of operations, we always look inside of the brackets first. And those look like what we did in the last lesson, where if I have 3 to the 2 times 3 to the 3, that is just 3 to the 2 plus 3, and all of that raised to the 3. And then here we have 4 to the 3 plus 2 raised to the 2. Okay. What that ends up looking like then, if I add these, I get 3 to the 5 to the 3 minus 4 to the 5 to the 2. And we just learned in our notes today, what do we do with these? We multiply them. So this becomes 3 to the 5 times 3 minus 4 to the 5 times 2. Evaluate that. That should be 3 to the 5 times 3, which is 15, minus 4 to the 5 times 2, which is 10. And now we're going to get some real big numbers here. 3 to the 15, I believe, is 14,348,907. And we're going to subtract 4 to the 10, which is 1,048,576. Reminder, you need to be able to plug these into your calculator. If you're going to plug these into your calculator, you do 3, and then you find this little arrow right there to the 15. Boom. That should give you 14,348,907. Some of you will have a button that looks like this. Okay, that means the same thing as my button that looks like that. Okay, some of you will have that little X to the Y. That's a little side note there. We got to make sure we're comfortable with our calculators. You will be using them a lot. Okay, so that gives us our final answer of, if I take that one and I subtract the other, I get 13,300,331. Kind of a fun number to say. All right, there we go. There's your final answer. Check my work, make sure I did it right, make sure you do it right. And if you did, we've got one question left to do together. 6 times 7 to the 2 plus 3 to the 8 divided by 3 to the 6 to the 3. All right, well, again, we're doing bed math. Some of you, I mean, I didn't get that many, but some of you gave me some good little mnemonic devices to remember bed math by. So we're doing everything inside of the brackets first, which means that we get to do one of the easiest steps first. 6 times 7, mental math, go. 42. Okay, 42 squared. Plus, when we have 3 to the 8 divided by 3 to the 6, remember that means that it's 3 to the 8 minus 6. That was in our notes yesterday or 2 days ago. Right? That was in our last lesson. So we're going to keep writing out this 42 to the 2, but we're going to evaluate what's going on in here. 3 to the 8 minus 6, that is 3 to the 2, and it's raised to another 3. So 42 to the 2. Now 2 to the 3, right? 3 to the 2 to the 3 means that it's 3 to the 2 times 3. So 42 to the 2 plus 3 to the 2 times 3, that's 6. And now we're at a place where we just plug it into our calculators. So 42 squared, what is 42 squared? 1,764 plus 3 to the 6, which is 729. Add those up, and your final answer should be 2,493. Okay. There you go. We did it. All right. If you got any questions, post them on the Google Classroom, or you can email me individually as well, or you can even leave a comment on the YouTube video here as well. Okay, there are your practice problems to work on. Like I said, take some time this week to just look after yourselves, relax, okay? It's your spring break. Enjoy that. If you are looking for, a little bit of a distraction or something to spend some time doing, you can definitely work on some math. And these would be the problems that I would work on right now, okay? I was able to give quite a few of those take-home booklets. If you want to take a look at some of those too, you can definitely do that. And there's some more practice problems in there. If not, enjoy your week off. And I will continue to be posting these video lessons not next week, but the week after. Okay, so have a good break. We will see you hopefully soon.